Had to step away for a sec, but finishing up our check for understanding here. In order to find our standard deviation, we have to use the standard deviation formula, which is in your notes from today. I'll put it here as well. It's going to be square root of p, 1 minus p, all over n. Okay, so the value that we're going to be using for p is 0.9. Then that means I have to use 0.1 here and all divided by 100. And when you solve that, you get 0.03. So we have our mean and our standard deviation identified. We can now solve this a couple different ways. I'm going to show you how to solve it using a z-score. So the z-score is the standardized test statistics. That's why I'm showing you this way. So I've got p hat minus p all divided by the standard deviation for p hat. All right, so this is going to be, let's see, my p hat value was 0.84. And then I'm subtracting 0.9, that's my value for p, divided by the standard deviation of 0.03 gives me a z-score of -2. So that's our z-score is -2. Now to find our p-value, two ways we can do it. One way is using normal CDF. I would use, oh, and let me actually sketch in our picture here too. So 0.84, we're looking for 0.84 or more extreme than that, or less. Okay, so my lower is going to be negative huge number. Upper, here I'm actually going to use the z-score of -2. And then for mean, I'm going to keep that at 0. Standard deviation, I'm going to keep that at 1. You also could fill this out with the actual values, the actual proportions. So for that, your lower would still be random big negative number. Upper now would be 0.84, mean, and standard deviation. So whether if you're using z-scores, that's cool, or if you're using the proportions, that's cool. Just make sure you're keeping them straight. Like you can't mix those up, otherwise like weird things will happen. Either way, we should be getting, oh, and then the other way you could do it is you could use table A. This is in your formula packet. I find that usually students prefer to just use their calculators. That's why I kind of steer away from talking about using that too much. But if you look at your formula packet and go past all the formulas to where it says table A, and then if you find -2 as a z-score, and if you slide over, it'll tell you the probability. So whatever method we pick, we should be getting a probability of 0.0228, roundabout there. Depending on which method you pick, you might get something a little bit off, and that's just because there's different ways to calculate it, but it should be pretty close to that. All right, for part E, what conclusion? So because 0.0228 is less than 0.05, we have convincing evidence that less than 90% of students can identify a skunk smell. The chances of us getting 84.84 are so small if it was just random and not if the 90% were true, that just that one result gives us evidence that actually the true value for the population is going to be less than 90. All right, that's it for part 3.